Hi everyone, today I'm going to show you our work at the Regulations Challenge task. The CoLing 2025 Regulatory Challenge aims to evaluate the ability of large language models, LLMs, to process regulatory data. The challenge includes 9 tasks, mainly summarizing recognition, financial data extraction and other practical application scenarios, and comprehensively testing the model performance through standard templates. Although many LLMs performed well in the tasks, they still faced challenges when processing regulatory texts. Text complexity: regulatory data contains a large number of professional terms, which increases the difficulty of understanding and generation. Regulatory differences in dynamics: regulations in different regions vary significantly, and regulations are constantly updated, requiring the model to have high stability and real-time performance. Insufficient interpretability: the current model lacks transparency, and the output process is difficult to explain, which limits practical applications. The above are the key issues we need to solve in the challenge. Next, I will introduce the coping strategies. To address the challenges of regulatory text, we designed a data construction pipeline that combines language screening, regular expression matching, domain embedding, semantic screening, and other technologies to ensure the quality and timeliness of the data. At the same time, we built a high-quality dataset of 30,000 examples, balancing domain-specific regulatory data and general financial data, providing strong support for model training. Now, let's take a closer look at the sources of these 30,000 examples. The dataset is divided into 2 main categories: financial regulations datasets and financial general datasets. The financial regulations datasets cover 24 specific financial regulatory tasks. These tasks include audit issue summarization and legal advice, audit-related Q&A, and audit assistant tasks, among others. On the other hand, the financial general datasets are composed of 2 subcategories of Fin-GPT, which focuses on data for specific financial domain tasks. SIG-FinTech, a bilingual financial instruction dataset designed to address broader financial tasks across languages. These structured sources ensure that our dataset is both comprehensive and well-suited to tackle diverse challenges in the financial, regulatory, and general financial domains. To ensure the quality and relevance of our dataset, we designed a robust data pipeline with several key components. First, we started with language filtering, where we use tools like FastText and the OpusMT model to guarantee consistency across different languages, ensuring that all selected data aligned with our target domain. Next, we applied regular expression matching, designing various filtering rules to refine the dataset further and improve its overall quality by eliminating irrelevant or noisy content. For domain-specific task filtering, we leveraged FinBERT to evaluate the relevance of each sample to financial regulatory tasks, selecting only the most suitable data to meet our goals. Then, we focused on quality optimization by integrating classifiers and perplexity-based methods. This step helped us prioritize high-quality, meaningful data while excluding low-quality samples. We also addressed toxic content removal, identifying and removing sensitive or harmful content to ensure that our dataset complied with ethical and regulatory standards. Finally, we implemented deduplication methods, including URL filtering, SHA-256 hashing, and jacket similarity, to remove duplicate samples and maintain dataset integrity. As a result of this comprehensive pipeline, we successfully curated a high-quality dataset containing 30,000 examples. Among these, 10,000 are financial regulation records, while the remaining 20,000 consist of general financial data. 1. This study fine-tunes LLaMA 3.2, 3B model, with LoRa technology, focusing on regulatory audits, financial texts, and proprietary datasets, audit regulation, SIG-FinTech, Fin-GPT, using supervised fine-tuning, SFT. 2. Data is pre-processed and scrambled, trained on 8 NVIDIA S6000 GPUs with a batch size of 2, and optimized via gradient accumulation. 3. The learning rate is set to 1.0 times 10 with a cosine annealing scheduler in 10% warm-up. Logs are recorded every 10 steps, and models are saved every 200 steps, overwriting old results. Half-precision training is used for speed and memory efficiency. The training runs for 3 rounds, and loss function changes are visualized to monitor progress, with logs and outputs saved for evaluation and deployment. We evaluate our model using 4 frameworks. The E1 framework is based on the 2025 Regulatory Challenge validation set, where all tasks except Task 6, not applicable due to lack of data, are assessed using BRT score F1 to measure semantic similarity between generated text and reference standards. The E2 framework uses the PIXIU Lemonade dataset and BRT score F1 to evaluate how well the model generates text aligned with regulatory language structure and semantics. The E3 framework, from the FinAI project, uses BRT score F1 for the Finca task and traditional F1 for other financial tasks to assess precision and recall of generated content. Finally, the E4 framework uses the official competition test set to evaluate submitted models on private datasets, ensuring fairness in the evaluation process. Next, we will present the detailed results from each of these evaluation frameworks and provide a thorough analysis. Performance in the E1 evaluation framework. Due to limited E1 data, a representative sampling strategy was adopted. The results show that the fine-tuned model outperforms the baseline model on most tasks except for the named entity recognition (NER) task. The slightly worse performance on the NER task may be related to task-specific optimization or data distribution. In E2, supervision-related, the model performed generally well, indicating that the model architecture enhancements effectively address the challenges of these tasks, with significant improvements observed in tasks involving complex reasoning and multi-step dependencies. In E3, finance-related, the model performed well on most tasks, indicating that the model architecture enhancement effectively dealt with situations of high domain-specific complexity, emphasizing its robustness and adaptability. The results show the specific scores of the model on various tasks, such as abbreviation recognition, definition, question and answer, etc. In the 2025 Regulatory Challenge, we worked with the LLaMA 3.2/3b Instruct model and enhanced it using a mix of translated Chinese regulatory datasets, the Fin-GPT public dataset, and our own internal financial Q&A data. We also built a complete data pipeline and used LoRa for fine-tuning, which significantly improved the model's ability to understand and apply financial regulations with greater accuracy and explainability. Our experiments showed that this domain-specific optimization made a big difference in the model's performance on regulatory tasks. This lays a strong foundation for developing better solutions for financial compliance and decision-making. Our key contributions include, first, developing Reg-LLaMA, which is specifically fine-tuned to tackle financial regulatory challenges, second, building a high-quality dataset to support regulatory tasks, and third, setting up performance benchmarks that highlight Reg-LLaMA's strengths in understanding financial regulations across multiple tasks. Here are our references.